Hi everyone. So in this video, I'm going to show you how to solve polynomial inequalities. So this falls in section 3.10 in your book. We have two more sections in this chapter, 310 and 311, and they both have to do with inequalities. This section is going to be polynomial inequalities, and this next section will be back to rationals with rational inequalities. So you might look at this and say, well, I don't see any equality, on the screen yet. So what we're going to do, I'm going to show you two methods, graphically and algebraic. So we're going to use a graphical method in a second to solve these two inequalities. So I'm going to put them over here on the side so I can leave room for my graph. So the first one I'm going to solve is negative x plus 1. So this function, I'm going to figure out, first of all, where it's greater than 0. And then I'm also going to solve, likewise, where this function is less than 0. So I'm looking to solve these two without really doing any algebra first. And then in the next couple slides, you'll see I'll focus on the algebra portion of it. Let me just move up a little bit. Okay, here we go. So let's now use what we know about finding a graph of this function. So it's already given to you in nice factored form. So if I were to come over here on the left here and give a sketch of this, you'll see everything we know how to do with graphing is going to be enough for us to solve these inequalities. So in factored form, I can see my x-intercepts, right? If I set each one of these factors to 0, I know that I've got x-intercepts at 0, at -1, and at 2 from setting those factors to 0. So if I were to graph this now, so this is a cubic, right? We've got 3 factors, 3 roots. So we know what a cubic looks like, and we also know that the leading coefficient in this one is negative. So if we were to graph this one, okay, let me get my intercepts ready. So let's see, I think we can get by with just the x-intercepts to do what we need to do. So we know there's a 0 there. We know there's a 0 there, and we know there's a 0 there. And because 0 is what is in between positive being greater than 0 and being less than 0, I don't really need the y-intercept for what I'm doing here. So I'm just going to sketch this and say, I know that this starts this way. I don't know how far down it goes, right? But it's not actually a big deal for this. It's going to have to come up. Each one of these has a multiplicity of 1. So really that's a pretty good sketch for what we need. Oh, actually, I didn't know the y-intercept because it went through 0, 0. So I'm going to use my graph to figure out, when I say if I'm solving this greater than 0, I'm really looking on my graph onto where this is above, right? This would have to be above the x-axis. Above the x-axis. That's where the y values, right? That's where the outputs are positive. We don't want them on the x-axis, this one, because it's strictly greater than 0. So if we look at, I'm going to actually highlight where it is above. Okay, so above the x-axis would be, whoops, sorry, I erased it. I often get those two buttons mixed up. Hold on, let me redraw my graph. There we go. Okay, so this spot right here, all here is where the graph is above the x-axis. And I go right up until it, but I won't include those zeros here because that would be where it equals 0. So we just figured out all the regions where this inequality is greater than 0. Okay, so what I'm going to do is use interval notation for this. And I'm going to say, let's see, the first region on the left would be anywhere from -infinity all the way up to that first 0 of -1. It's above the x-axis there. Then it dips below. But then it comes up again from 0 all the way until 2. That's the second spot that is above the x-axis. So we did that graphically. So let's now see if we can do, now we want to see where is it less than 0? Where's the output of my function less than 0? So we're really looking for where it is below the x-axis. Okay, so let me see. I don't know if I have different highlighter colors. Let's see, I think I do. I'm going to try to highlight it in a different color. So below it would be, there we go, all here. Now, if they had an equal to, I would include the 0, but these ones were strictly greater than or strictly less than. So now for being below the x-axis, all my highlighted in green, so that's going to be anywhere in between -1 and 0, and then again after 2 to infinity. So really this includes the entire graph except for the actual zeros, because the actual x-intercepts is where it equals 0, and neither one of these included 0 in it. So there's a way we can do this without really knowing too much more. We just really used what we knew about getting the x-intercepts and getting the graph of this, and then use the graph to analyze these. So let's look at our next slide, and the next one is going to be how to do it algebraically without having to graph it. Okay, so for this one here, we're going to try to solve x squared minus 7x plus 6 greater than 0 algebraically. We could do it the very same way we did the one before, and we could graph this. This one's a parabola because it's only a quadratic, and figure out where it is above the x-axis since it's greater than. But let's try to do it algebraically. So the first thing we're going to do here is we still really need those roots. We're not going to be able to get away with not having the roots. No matter which way we do it, we've got to find the zeros first. So that's what we're going to do here first. We're going to get one side, in this case, we're going to get one side equal to 0 so that we can factor it. Get one side equal to 0 and factor. All right, so I already have one side equal to 0. And this is a pretty basic factoring one. There's no GCF to pull out. And I can just come up with my factors like this. Let's see, x and x, 6 and 1, both minus in order to get everything we need there. So once we have it all factored, our second step is going to be to find our zeros, find our roots. Right, we could say or our zeros. That means the same thing. And then what we do with them, okay, so our zeros in this case would be x equals 6 and x equals to 1. So this is what I do next. So my next step is I'm going to put my zeros or my roots on a number line. Okay, and I'm going to choose a test point in between all of my zeros. I'll show you what I mean in a second. So I'm going to choose a test point in each interval. Okay, so it's going to look like this. I'm going to draw a number line, and I'm going to put each one of these on here. So sometimes you can label 0 in there if you want as well, but let's see. I'm going to put, this is going to be 1, this is going to be 6. And so I'm going to choose a test point, anything that's in between in each one of these intervals. So I always use 0 as a test point if I can. So 0 would be over here. It would be a good test point to the left of 1 because it's in that interval. So now I have to pick something in between 1 and 6. So I'll just pick 2. It can be anything in between there. And anything to the right of 6. So maybe I'll pick as my test point 8. We don't have to have the same test points, but they just have to be in those intervals. Okay, so now I'm going to test each one. Okay, so my fourth step is I'm going to test each test point to see if it gives a true statement or not in the inequality. Test each test point in the inequality. And this will tell us which intervals work and which intervals don't. So that's why we're using these. We're trying to figure out, you know, is my solution, is it in between 1 and 6? Is it to the right of 6? Is it to the left? Is it more than one of those intervals? That's what the test points are going to help us do. So it's going to look like this. You can make a little chart, right, and say, okay, here are my test points. And then here is if it works or not. So this, I usually just say like yes or no, or true or false, whether it works or not. So let's test each one of these. We're going to test 0, we're going to test 2, and we're going to test 8. So each one of these you have to put into the inequality and see if it works. So when you test 0, you can test it up here in the factored form, or you could test it up in the original one, whichever one you find easiest. I think I'm going to put 0 into the factored form and say, okay, when I put it in the factored form and I put 0 minus 6, I get negative 6, and 0 minus 1, I get times negative 1. So if I look at that, is that greater than 0 is my question. And so if I multiply that out, I'm really looking just for the sign. I don't actually care what the number is, but if I do that out, I get a positive, and that is greater than 0, so this is a yes. So what that means is that 0 is a yes region, meaning it's a true. Okay, so I know that part of my solution is from negative infinity to 1. And I'll see now, let's see if it works when we do plug in 2 and if we plug in 8. So if I plug in 2 into my factored form and do minus 6, I get a negative 4. And then 2 minus 1, I get a 1. And I'm asking myself, is that greater than 0? That should really kind of be a question, right? That's what we're trying to figure out. And if I multiply that, I get a negative. So a negative is not greater than 0, so this is a no. So that region's not in my solution. And then we'll test 8. So sometimes these intervals alternate between yes, no, yes, no. Sometimes you have 2 in a row, so we're not really sure what 8's going to be. If you think of a parabola, you can kind of come up with it. But, you know, we don't want to generalize these rules too much, because then we'll get to one with a cubic, and that won't necessarily work. So let's plug in 8 to my factored form. If I do 8 minus 6, I get a 2. And if I do 8 minus 1, I get a 7. Is that greater than 0 is my question. And that's a positive when I do it out, so it's definitely greater than 0, so we have another yes region. So let me now, so we found our solution. Everywhere where we said yes is our solution. Move this up a little bit. And so now we're ready to write our solution out. Okay, so all my solutions are where I wrote yes, so that would be from negative infinity up until 1. This one did not have an equal to again, so I'm not going to put the hard bracket, I'm going to put a soft bracket. And then it picks up again from 6 to infinity. And if you look at the shape, if you just kind of visualize what this parabola looks like, it does open up. So it does make sense if you visualize it that it's greater than 0 at the tail ends, you know, as it's opening up. So there's my solution right there. All right, so we're going to do one last one on my next slide. So we're going to try to solve this one right here the same way. So you may want to just pause the video right now, write it down, and get it started and see if you can come up with the beginning of it. Maybe you can get to the point where you've got, you know, follow those steps where you've got one side to be greater than one side equal to 0. Got everything on one side, and then start your factoring, and then see if you're able to get your factors, and then we can start from there. Okay, so I'm going to start doing here. So I'm going to bring over this term over here. So I'm going to add this over, right? And I'm going to add this over. I'm going to put them in the front to get x to the third plus 2x squared minus 4x minus 8 less than or equal to 0. So my inequality is not changing at all here because I'm just adding and subtracting things over. I'm never multiplying by any kind of negative. So I don't have to worry about reversing my inequality at all. I'm trying to sprinkle in as much factoring practice with these as we can get. Okay, so you're going to see this example will practice factoring by grouping. We have 4 terms here, so let's factor this up. So between the first 2 terms, I will pull out an x squared, and I'll be left with x plus 2. And on this one, I'm going to pull out as much as I can, which will be a minus 4. and I'm left with an x plus 2, right? That's got to happen if we're going to move forward here with these like terms. So now I'm going to have x plus 2 times x squared minus 4 when I do my grouping. I pulled out the x plus 2, and I was left with the x squared minus 4. All right, I'm going to do one more step of factoring here, because this second one right here is going to factor into x plus 2, x minus 2, less than or equal to 0. All right, so let's find our factors. Whoops. I don't know why it's going in pieces like that. All right, here we go. Let's find our factors. So we get -2. We get that twice. That kind of helps us because we have less intervals now to try. And we get 2. Okay, so we've got to draw our number line. We've got to put -2 and 2. In the last one, I don't know if I put the circles. I don't think I did, but if I go back, it messes up the audio if I go back to the slide. But this one, because we're looking for less than or equal to 0, so it will be filled in circles here. The last one on my number line, I should have just done an open circle above each one of those to show the endpoint, okay? And we're going to figure out what happens in between these. So we're going to have to pick some test values. So if 0 is not one of your actual roots, always pick 0 as a test point wherever it fits. So in this one, it fits right here because it's in between -2 and 2. And then on this side, just pick anything over here. Okay, so I'm going to pick x equals 4. And then I guess I'll just over here pick -4. So now let's go and test. Okay, let me just move this up a little bit. We don't need that top part anymore. Okay, just want to give some space here. All right, so let's, we're going to test, here's our test points. And then if it's, I'll just say true or false. I usually write yes or no, but I think my open math in your book probably says true or false. So we're going to test x equals -4, and we're going to test x equals 0, and we're going to test x equals 4. All right, so let's just plug them in and see what happens. So if you come up to the factors, you know, I'm looking at the factored version, and I'm plugging in a -4 everywhere. Okay, so I'm looking at this right here. Let me circle it. And I'm going to plug in my -4 for each one. All right, so if I do -4 plus 2, I get -2. And then again, -4 plus 2, right, I get another -2. And -4 minus 2, I get a -6. And my question is this less than or equal to 0? That's what we're trying to figure out for us to say yes or no. So I'm not even multiplying out the numbers. I'm just looking at the sign. And this is going to come out to be a negative, which is less than 0. So this is a yes, whoops, or a true. So this region right here is a good one. So let's do it for the other ones. Okay, so 0, I personally think 0 is easier to go back up to the original one when you had everything on one side and put it in there and see if it works or not. You can put it into the factored version as well. But if you do, you end up getting, this one is going to work. So let me just put it, I'll just do it in the factored one. So to be consistent. So if I plug in a 0, I get a 2 times 2 times -2. Is that less than or equal to 0? So that also comes out to be negative. So yes, that is true. And then let's try the 4. When I plug 4 into the factored version, I get a 6, another 6, and a 4 times a 4. So regardless of what number that is, I'm doing 3 positives. Is that greater than, or is that less than or equal to 0? It's not, because you end up getting a positive on the left, which is not less than or equal to 0. So this would be false. So this is a no region over here. And let's see, the other one we found to be a true. So see, on this one, you've got 2 trues in a row, which can happen for a cubic like that. So we have our solutions, right? Our solutions here, I'm going to highlight them. Our solutions are right here, all the way to here, actually. So what's this one, actually, we don't even have to use a union, right? Because our solutions are all in one interval. So our solutions are going to be everywhere from negative infinity all the way up until 2. And that will be a closed bracket because it includes that endpoint because there's an equal to on it. So that would be my solution. Okay, so there's 2 examples of solving algebraically. This is what we're going to work on during the second half of class today together, and some in groups as well.